So if you take likewise in the same pH scale continuation, actually sometimes if we take the biological applications of pH scale, if you take, you know very well that a tooth decay is due to the pH value. If it is less than 5.5, means the acidity of the food with sugar increases when the pH is less than 5.5. If the pH is less than 5.5, the acidity on the food and sugar increases by this the food, whatever the food and sugar, they try to get oxidized with the oxygen which we try to inhale. With the help of oxygen, the food and the sugar, the food in the form of sugar, it gets oxidized and it starts attacking the protective layer, the tooth. If you take the tooth surface, it has a protective layer that we call it as enamel. This enamel actually contains a compound called calcium phosphate, Ca3PO4 taken twice. It contains calcium phosphate. Okay, this calcium phosphate enamel gets destroyed, okay, if the pH is less than 5.5. The pH is less than 5.5. So this is one important application of biological application of pH scale. Also sometimes, you know, the honeybee and nettle plant, they release acids which cause irritation and pain. They cause irritation and pain to us. So here what we are going to do is, for example, nettle plant in particular, it is going to release an acid called, that is HCOOH. It releases an acid called HCOOH. HC double bond HCOOH is nothing but methanoic acid, which causes this methanoic acid released by nettle plant causes irritation and pain. So this irritation and pain has to be immediately nullified. It has to be nullified or neutralized by taking certain neutralizing substance. So likewise here, even in our stomach also, excess of HCl is produced, then that leads to gastric ulcer. Then that means the burning sensation in stomach, indigestion problem, burning sensation is gastric ulcer when there is excess producing of HCl in our stomach. If sufficient amount of HCl is produced by the gastric juice during the digestion of food, then that is automatically absorbed by the body. But once the food which is not digested is deposited, it stays there in the stomach without getting digested, then because of that the gastric juice is going to produce some excess amount of hydrochloric acid. This excess amount of hydrochloric acid ultimately shows the adverse effect in the form of gastric ulcer. So this gastric ulcer has to be immediately minimized in our stomach. That's why for this gastric ulcer we add antacids. We call them as antacids. The best example of antacids is milk of magnesia. Whose pH value is around 10 to 11. pH is 10 to 11. This milk of magnesia is nothing but, that is magnesium hydroxide in water. So this magnesium hydroxide in water goes and attacks the HCl present in stomach, and it reacts with magnesium hydroxide and it neutralizes. Reaction gets neutralized, you get magnesium chloride, salt plus sufficient amount of water is also produced. So this is called neutralization reaction. So next part of our discussion here in acids, bases and salts is, that is family of salts. So in the family of salts, if we take, I am giving you two salts here, sodium chloride and sodium sulfate is one set. If you take sodium chloride and sodium sulfate, I will say that this sodium chloride as a salt and sodium sulfate as a salt, both of them belongs to sodium family. They belong to sodium family. Why? What is the reason why we are calling them as sodium family? Because if you take sodium chloride, in sodium chloride we have sodium, so it dissociates in the aqueous form, it dissociates to give Na plus of aqueous and Cl minus ion of aqueous. So that means sodium chloride is able to give Na plus ion, sodium cation. And if you go for sodium sulfate aqueous also contains sodium ion. Of course it is giving 2 moles of sodium cations plus 1 sulfate anion aqueous. So what we are noticing here is this is called common ion. Both sodium chloride and sodium sulfate, both of them are having the same common ions, that is sodium ions. That is why this sodium chloride and sodium sulfate, they belong to a common family, that is sodium family. These are common ions. We can call them as common ions. Similarly, if you take sodium chloride and potassium chloride, if you take sodium chloride aqueous, it is giving Na plus Cl minus ion aqueous. And if you take potassium chloride aqueous, it is able to give K plus of aqueous and Cl minus ion of aqueous. So here you are finding that the chloride ion in sodium chloride and potassium chloride, the chloride ion is a common ion. The chloride ion is a common ion. It is a common ion. That's why I can say that both the sodium chloride and potassium chloride, they belong to chlorine family. Sodium chloride and potassium chloride belongs to chlorine family. They belong to chlorine family because chlorine is a common ion. In both sodium chloride and potassium chloride, chlorine is a common ion, that is Cl minus.